Before we move on past number 7, I do want to show you how to do this on Desmos because it does something kind of neat. So if we want to find the area under the standard normal curve between 1.5 and 2.75 using Desmos, let me just show you how to do that. It's in the notes, I had written it earlier, but you just type in normal, D-I-S-T, and then you have to tell it what the mean and standard deviation are. So mean is 0, comma, standard deviation, okay? And notice it actually draws this here. If we zoom in, you can see it's a standard normal curve, like that. And then we want to check the box that says find the cumulative probability. So right now it's finding the area under the entire curve from negative infinity to infinity, which is 1. If you wanted to find from negative infinity to 1.37, I think that was one of our problems, it'll find that for you as well. And it even draws the picture. So the problem that we just did, number 7, we were finding the area between 1.5 and 2.75. So we just adjust that. So let me zoom out a little bit. It shades it in there, and then it gives you the answer right here. So Desmos does a really nice job of doing that and giving you the picture to look at, which is kind of fun. So in case you don't have your calculator, you can go back and do all of these problems just like this. So let's take care of these last few. I'm going to do another one on the table and one more on the calculator. So we want to find the total areas under the standard normal curve to the left of negative 2.5 and to the right of 3. So let's draw this. Here's our normal curve. So negative, here's our middle. Negative 2.5 is down here. So we want to go to the left of that. That's going to be very small. And then 3 is way up here and to the right of that. Also very small. Okay, so our answer is not going to be big. So for this first part, we can look that up on the table. We're just looking for everything to the left of negative 2.5. And then we also need everything to the right of 3. Okay. Now, the table only does to the left of. So to do this portion, we're going to have to do 1 minus the area to the left of that. Okay, and then this one we can look up exactly how it is. Okay, I missed a parenthesis there. There we go. Okay, so now we're going to pop over to the table. Here. First, we want area to the left of negative 2.5. So we're in table A. So here's negative 2.5, and then we need to go all the way over here. So we get 0.0062. And then we also need area to the left of 3, and that's going to be on the next page. We're going to go to 3.0, so 0.9987. Hopefully you already wrote those numbers down. Okay. So this one was 0.0062, and this is 1 minus 0.9987. And when you do all of that, you should get 0.0075. Okay, and we said when we drew the picture that was a really small area. All right, number 9. We'll do this one on the calculator. We're going to find the total area under the standard normal curve to the left of negative 1.23 and to the right of 1.23. All right, so negative 1.23, I don't know, maybe right here. And to the right of 1.23, it's going to be here. So we're looking for this area and this area. Now this problem is a little bit different than the last one. Since these z values are the same, the area to the left and the area to the right are also going to be the same. So we really only have to do one of them in the calculator, and we're just going to double it. So we're going to do 2 times the area to the left of negative 1.23. Okay, it'll just save us time in the calculator. So we'll go over to the calculator, and where did the calculator go? There it is. Go to distribution. I'm going to do a normal CDF. I decided to do this lower one, so my left bound is going to be negative infinity, so negative 1 double E 99. The upper upper bound is going to be negative 1.23. Mu is 0, sigma is 1, and that's going to give me 0.1093. So then I'm coming back over here, 0.1093. And then when we multiply that by 2, we should get 0.2187. All right, the last thing, do I have room to scroll down there and catch it? There it is, barely. Last thing we want to do is interpret, okay? So interpret means explain in words, and I know you can't see that super well. We want to interpret the P of Z is less than or equal to negative 2.76, okay? So in words, this is the probability that a random variable or that a z-score is more than 2.67 standard deviations below the mean. Okay, so it's the probability that a randomly selected z-score is more than 2.67 standard deviations below the mean. Or you could also say it is the area under the normal curve to the left of negative 2.67. Okay, so that's what it means by interpreting these. I strongly encourage you to read this section in your textbook and make sure you're understanding how to interpret these. Look at how the textbook writes them as well, because that'll really help with your understanding.